Okay, welcome back. Now we're going to introduce another definition, the definition of instantaneous rate of change, because we can apply this to many different situations. Okay, so the instantaneous rate of change of a function, f of x, at a value a, is the derivative f prime of a. Very simple, straightforward. Okay. That is the definition of instantaneous rate of change. Okay, so again, the slope of the tangent line, the instantaneous rate of change, the derivative of a function at a point are all saying the same thing. Okay, so let's do an example. So let's talk about rate of change of temperature. Okay, so it says a homeowner sets the thermostat so that the temperature in the house begins to drop, from 70 degrees at 9 p.m., reaches a low of 60 degrees during the night, and rises back to 70 degrees by 7 a.m. the next morning. Suppose that the temperature in the house is given by the following function. Okay, so this represents the temperature in the house at time t is equal to 0.4 t squared minus 4t plus 70. And this is for 0 less than or equal to t less than or equal to 10, and where t is the number of hours past 9 p.m. Okay? Find the instantaneous rate of change of the temperature at midnight. Okay, so now midnight, what is t? So that's important to make sure we understand in context of the problem. 0 hours is at 9 p.m., right? And so that means 10 hours, or t equal to 10 would be 10 hours after 9 p.m., okay? Which would bring us to 7 a.m. Okay? So midnight, right? What is t at midnight? So that would be at 3 hours after 9 p.m., right? Okay, so t equals 3. Okay, so now what we want to do is we want to find the instantaneous rate of change in temperature at midnight. Okay, so that means we want t prime of t, which is going to equal the limit as t approaches 3 of what? It's going to be f of t minus f of 3 over t minus 3. Okay? And so I get the limit as t approaches 3 of what? It's going to be t squared minus 4t plus 70 minus, well, at f of 3, right? So f of 3 is going to be 9 times 0.4, which is 3.6. So this would be minus 3.6 plus 12 minus 70 over t minus 3. So notice again, things cancel, 70 minus 70. And so now let's simplify this even further. So t approaches 3 of, now what happens here This is, again, it's going to be 0.4 t squared minus, let's see, we have 4t and, well, that's it. Okay, so minus 4t, and then what do we have? We got 3.6 minus 3.6 and 12. So 12 minus 3 is 9, minus 0.6 is 8.4. So we get plus 8.4 over t minus 3. Okay, now, here's what we're going to do. Let's factor 0.4 out of there. Because we can't factor this the way it is. We've got to be able to get this t minus 3 out of there. So let's factor the 0.4 out to get all whole numbers and see what we have. So we get the limit as t approaches 3 of 0.4 times t squared minus, so that would be 10 t, and then let's see, that would give us a plus, and let's see, 12, plus 12. Okay, and now we can factor that. We can factor that as, oh, hold on a second. Oh, no, oh, wait. Oh, so, hold on, 21. 21, not 12. 21, right? 10t. So, 4 is 10. Right, okay. So now, over t minus 3, and now, this is going to give us the limit as t approaches 3 of 0.4 times t minus 3 times t minus 7 over t minus 3. These cancel, and I get the limit as t approaches 3 of 0.4 times t minus 7. Of course, this is continuous, right? So we can use our properties of limits, your rules of limits, so we can actually just evaluate this at 3. And so this is going to be 0.4 times negative 4. And so it's going to be negative 1.6. Okay? So what does that mean? It means that the instantaneous change of temperature at midnight is negative 1.6 degrees Fahrenheit. So again, this was in degrees Fahrenheit. Okay? So that means the change in temperature, the instantaneous change in temperature at midnight is that it's decreasing at a rate of 1.6 degrees Fahrenheit. And that's the answer. Have a great day.